Today we are going to discuss about the topic is computer networks. Introduction to computer networks. First see the content, introduction, data and information, data communication, then data representation, data flow, next network types, last one is the topologies. First we see the introduction. What is computer network? A collection of computing devices that are connected in different ways in order to communicate and share the informations. Usually the connection between computers in a network are made using the physical wires or wireless. However, some connection are wireless using radio waves or IR signals. The main objective of data communication networking is to enable seamless exchange of data between any 2 points. The exchange of data or information takes place over a computer network. The second one is data and information. Here the data refers to the raw facts that are collected, while information refer to the precise data that enables us to take decision. The word data refers to any information which is presented in a form that is agreed and accepted upon by the makers and users. The data communication, it is the process of exchanging data or information. In case of computer networks, this exchange is done between two devices over a transmission medium. The transmission medium is a wired or wireless. This process involves a communication system which is made up of hardware and software. The hardware part involves the sender and receiver devices and the intermediate devices through which data passes. In the second part is software. It involves certain rules which specify what is to be communicated between two devices and how it is to be communicated and when. It is also called as a protocol. The third one is the characteristics. The characteristics of a data communication system is based upon 4 characteristics. The first one, data delivery, accuracy, timelines, the jitter. First we see the delivery. The data should be delivered to the correct destination, that is correct receiver and the correct user. The second characteristic is the accuracy. The communication system should deliver the data accurately without introducing any errors. The data may be corrupted during transmission, affecting the accuracy of the delivered data. The third characteristic is timelines. The system must deliver data. The data is audio, either or video, in a timely manner without delay. Such a data delivered is called real-time transmission of data. The fourth one is the jitter. It is the variation in the packet arrival time. Jitter may affect the timelines of a data being transmitted. These 4 characteristics made in the data communication system. The next topic is the components. Here the data communication system has 5 major components. The diagrams represent the components of data communications: center, medium, message, receiver, then protocol. First we see the message. That's the data. It is the information to be communicated by the sender to the receiver. The second one, sender or transmitter. It is any device that is capable of sending the data. The third one, receiver. The receiver is a device that the sender wants to communicate the message. Next, fourth one is the medium. That's the transmission medium. It is the path by which the message travels from sender to receiver. It can be wired medium or wireless medium. The last component is the protocol. It is an agreed upon set of rules and regulations by the sender and receiver to communicate data. A protocol is a set of rules that governs data communications. A protocol is necessity in the data communication. It represents an agreement between communicating devices. If without protocol, 2 devices may be connected but it's not communicating. Next one is the data representation. Here there are different forms in which data may be represented. Okay, first we see the text format. Here the text includes combination of alphabets and small case as well as the uppercase. It is stored in a data pattern of bits. The second type is numbers. It includes a combination of our digital form, that is 0 to 9. The third representation is images. In system, images are digitally stored. A pixel is the smallest element of an image. The fourth type is audio type. That data can also be in the form of sound, which can be recorded and broadcasted. Audio is a continuous, it's not discrete. Next is the video. Here the video refers to broadcasting of data in form of picture or movie. The next one is the data flow. Devices communicate with each other by sending and receiving data. The data can flow between the two devices in the following ways. Here we can say three way of data direction. The first one is the simplex, off duplex. The third one is the full duplex. First, the simplex. In simplex, communication is the unidirectional way. Only one of the device send the data and the another one only receive the data. For example, a CPU send data while a monitor only receive data. Here see the diagram A. Here's the simplex representation. It's the direction of data. It is unidirectional. Next type is half duplex. In half duplex, both the station can transmit as well as the receive the data, but not at the same time. When one device is sending, another can only receive. For example, walkie-talkie. The third type of data flow is full duplex. In full duplex mode, both stations can transmit and receive at the same time. For example, is a mobile phone usage. It's the diagram representation of simplex, off duplex and full duplex. Here only difference is the direction of data and the data transmission time. Next is the computer networks. The computer networks are used for the data communication purpose. A computer network can be defined as a collection of nodes or devices. A node can be any device capable of transmitting or receiving the data. The communicating nodes have to be connected by a communication links. Next, a computer network should ensure the three performance factors. One is the reliability, security, then performance. The reliability of the data communication process, security of the data, performance by achieving higher throughput and the smaller delay times. The next, network types. The networks are categorized on the basis of their sizes. Here, three basic categories of computer networks are. The first one is the LAN. It is usually limited to a few kilometers of area. That's a short distance. We are using the LAN type. It is designed to provide local interconnectivity. The second is the wide area network, the WAN. It is made up of all the networks in a large area. A network that connects two or more local area networks. The third one is the metropolitan area network. This is the MAN. It is of size between LAN and WAN. It is larger than the LAN but smaller than WAN. The communication infrastructure that have been developed in and around large cities. Here we consider some standard organization in the field of networking. The standards are created by the standards creation committees, firms and government regulatory agencies. Here see some standard organization we are using in the network field. The first one is the ISO, International Organization for Standardization. The second one is the ITU-T, it's the International Telecommunication Union Telecommunication Standard. Next, ANSI, the American National Standard Institute. The last one is the major we are using the standard organization is the IEEE. Here see the diagram for the LAN connecting computers to hub in a closed set. Here using the hub devices. The examples of forms ATM, MPLS, frame relay and some examples for regulatory agencies, the FCC. Next one we see the topologies. Here difference between network topology and physical topology. The network topology defines structure of network. But the physical topology, the layout of the wire or media. Physical topology is part of network topology. In physical topology, we have 5 types of topologies. Bus topology, star, ring, mesh and tree topologies. We will discuss 2 types of topologies only in this discussion. Here first see the ring topology. Here all nodes connected to one another in form of closed loop. Here see the ring topology structure. Here it is a closed loop. Expensive and difficult to install but offer high bandwidth. Here point-to-point connection with only 2 devices. Here the data is passed in one direction only. Here moves until it reaches to its destinations. Each device is connected with a repeater. Here using the device is repeater. One data always circulate for fault detections. If device does not receive a data for specific time, it generates the alarm. It's the ring topology. Next we see the star topology. Here see the structure of star topology. The center part is the hub. Here using the 7 to 8 nodes are connected in the star topology. The connected all devices with a central point. The central point can be hub. The data transmitter reach of to central point who decide where to send the data. The bottleneck occur because all data passed from the hub center device. It's less expensive and easy to install. If one leg is down, it still remains active. The drawback of the star topology is depends on one central unit. Mostly the star is used in the LAN type of network. Thank you.